Hey everyone, welcome to another video on Blender geometry nodes. In this video, you will see about geometry read nodes. What are geometry read nodes and what data is behind those read nodes? I release new videos on a weekly basis. Please subscribe to my channel so that you'll be notified when I upload a new one. This is Jay from CJ Academy. Let's start. I have the default cube and the custom workspace. So I have covered about this in a separate video. I'll put the link in the description. Let's disconnect this. We don't need it. Let's bring in the grid. Grid node is nothing but the plane in XY axis. And let's bring in the geometry read nodes, all of it. So when I say this read node, the read node is there in for other geometry types also. In case of geometry, instead of mesh or curve, this is a general geometry read nodes, which includes both mesh and curve related information. So that's why the radius node is also available here. Let's increase the grid to 5 and vertices to 8. You'll be able to see it in the wireframe mode. So we have good number of divisions. To understand the ID index or the other nodes, let's bring in the instance on points. Grid position or grid vertices will be the points, and bring in the cone for the instance. Let's put this point 1, this point 2, and connect it. Okay. Now let's bring in the compare. It's map now. So the setup is very similar to the viewer node video I have covered, but we have slight difference in this case. First index and ID we will see, and then the other nodes. So I'll try to control the selection. You can see one is removed. Okay, remove it again. The 0th index, okay, is removed because the condition for selection is check for the IDs and choose only greater than 0. And it's a float value. We should actually consider the integer because it's a random value on integer level. So now 0th index is gone because this is greater than. If I say greater than or equal, then this is also considered. If we go for equal and then say move the slider for the value, you can see how it changes. Same for less than equal or greater than equal. Okay. Now I have a selection, right? So if I put index instead of ID, what happens? There are no change because if you hover over the ID node and index node, you can see it. ID is a random stable identifier which gives the information about the point. Let's say 10 points are there means the 10 points will have its own identification number. Whenever the ID value is not there, it will give you the value of index. That is why in most cases index and ID are same. In cases where ID doesn't have its own value, it will give the index value of the geometry. Here the geometry in the sense grid node. Okay, because we are connected to the points and the point details is about the grid. That's why you don't see any difference between ID or index. There are some intricate differences between the two that we will see in a separate video. For now, know that ID is a stable random identifier, just a number value, and index is nothing but integer value. Okay, so integer value for each of the points in the list. I can give you one hint now. Key difference: ID you cannot see it here. Okay, the ID node is not visible, but the index data is visible. So let's connect this to viewer node, and then we can see it. It needs a geometry context. So let's bring in the geometry. What you see here, the very first column, this is the index data. For each point, there is a value assigned to it. And ID, when it doesn't have a value of its own for the geometry, wherever it is connected, it will give the index value. So this is how index and ID works. Next, we will see about named attribute, position, and normal together. For that, I'll disconnect this. this as well. Okay. So instead of grid, let's bring in another called icosphere and let's connect it. Okay, now icosphere's point is considered for the instance, and I will connect this to the attribute. So named attribute is nothing but any attribute that is created or that is already available for the geometry that will be taken. In this case, points of the icosphere is considered. We have valid attributes for that. For example, position. This is same as this position node. Okay, now you can see. The position attribute is nothing but the XYZ value. In this case, let's bring in the join geometry to see icosphere and the instanced cones together. Okay, then we'll have a better understanding. Now, if you see, position attribute is used for the each point and that is considered for the instance. Okay, if you see here, position node I have taken with the less than or equal condition for the float value, and you can see whatever is less than or equal 0.3 as a point position value is considered. This is not the exact way to see how this works, but let's say this is also a way to consider the selection. Now let's move it out of the selection control because we want to keep it in all the places. Let's go for the rotation because this is an interesting point. Okay. Now I'll remove this. So let's see about position. These two are same and normal nodes. Now I'll consider the points here. That's where the instances are created. Let's try to rotate it along the z-axis. Okay, this is a, let's say, an interesting way to create geometries, and is also a question that often asked in forums for Blender. Okay, now we need to bring in the data conversion for rotation. If I connect this position value to the rotation, it's not exactly the same way as we expected. We also need to control it, but this is a vector value and this is a radiant value. This is degrees. Okay, this is XYZ value in floating vector value. There is not a, it's a brute way of converting a vector value to a radiant value. So the actual or the correct way to do it is, so if you see there is a color change, this means a data conversion has happened internally. To have a proper rotation or proper conversion from a vector value to a radiant value, you need align rotation to vector as node. And what this does is it takes the not rotation value but the vector value, okay, and convert it into the radiant value and feeds into for the rotation. X, Y, Z is calculated for each point on its local axis, not the main central axis. That is the position node does. And normal, if you choose, normal is nothing but a subset of position. Let's say position gives you X, Y, Z axis of any given point on its axis, and normal gives you just the Z axis information. Okay. So in this case, both similar to ID and index, we don't see any difference because position gives you XYZ value of the point and normal also try to calculate on the same local axis for the point. So the end result is same. Now the key difference what we can see between normal and position is when we have points on the faces. Let's bring in mesh to points node. What this will do is it will create vertices, the new points on the geometry based on our request. Now we have request, we will take faces. Now you see how the thing already changed in a good way. So this is something most people try to attain where they have a face and they want to keep an object at the center of the face. Okay, this is one way to do it. I have connected position here. What happens if I connect normal? Now you see the difference. It doesn't change anything because normal means it takes the z-axis, and in this case When we try to evaluate new points, it doesn't consider because it just still trying to consider the icosphere as whole. And what happens? Z-axis is up, and this is all up in one direction. It takes the global axis, and if I connect position, this is now changed because it's taking the local point, point's local axis. So I'll show you again. So normal, and if I say this is also similar, this also same as this now. So if I connect this, you can see it takes the individual points local z-axis. That will be from the face to outward direction. Okay, this is a cool way to construct some interesting geometries. This is the key difference between normal and position when you add points manually and not coming from the geometry itself. So this is one key difference we see. There are many different ways to utilize these normal and position node. We will see about those in detail as we try to create some complex geometries. Right now we are trying to focus only on the theoretical part with some random examples. The last is the radius node. Though we are not covering much on the curves at the moment, you can say radius node can also be used in a similar way how ID and index is used. Okay. ID and index is used as a for the point, a random number or an integer in case of index. For each point evaluated, the radius of that point will be fed into the geometry calculation. This is useful for curve to mesh node. We see where you have curve and profile curve, and by checking the profile curve, I mean for the guide curve, that is the curve, using the sample curve. Okay, and this can be used for the selection node where you can bring in the radius data for the geometry creation. So we'll see about the radius node, not exactly about radius node, but the curves, how to create different kind of geometries using curves in a separate video, and by then we will be extensively using radius node. Know that radius node has data about curve. If there is a curve geometry, radius node will take wherever the curve geometry context is involved. In this case, anything that we added here, a spiral or something, that is what will be considered. Spirals, individual points, radius data is what this will have now. And if there is no geometry, there is no data to consider. Okay, so these are the read nodes, and they are very useful when you go for a complex geometry creation where you want to read some data and then process it further. Okay, so that's it about read nodes. So we have covered a lot, and we have ended up creating a lot of nodes here now. Just go through it. If you have any questions, please let me know. If you find this video useful, please like it, share it with your friends. If you want me to cover any specific topic in Blender geometry nodes or any other aspect, please let me know in the comment section. Please subscribe to my channel. I'll see you in another cool video. Thank you. Bye.